conducted by Clive Chen, Principal Solution Architect at OpenHive. Here we'll be talking about the federated learning, privacy preserving, and scalable generative AI. So here, let's welcome Clive here.
Hi, everyone. My name is Clive Chen, Principal Solution Architect of OpenHive. Thanks API Days Hong Kong for having me here today to talk to you about federated learning, privacy preserving, and scalable generative AI. Today, I will share some of our team's recent federated learning project experience and the development in Hong Kong. Moreover, I will talk more about the latest evolution of federated learning and how he helped to improve the large language model. You know, this is the hottest topic here of AI, and make the large language model more scalable and secure to collaborate, to train for the different party. So let's get started. So what is federated learning, or our solution, OpenHive federated learning solution? Actually, why we have this solution, because a lot of customer enterprise, they are not having sufficient data to understand their customer, their prospect. While they are doing a lot of transformation, they want to do a data-driven solution. But enterprise usually have their own data. So when they want to do analysis, they would like to acquire more data to have a more holistic view of their customer. So they could do more propensity model or prediction model on income, wealth. They were looking for customers' household spending experience, pattern, or their preferences. So, but privacy is the utmost concern of a lot of organizations. So there's not easy for the enterprise to acquire alternative data from other parties. So with traditional machine learning, the model training need to be have all the data in a single data platform. So that's why other party who is the data owner, they have to share the data to the data requester to do the training, and this a lot of concern of the privacy. So with federated learning, we break this issue of we break the data silo issue, and multiple parties, they can collaborate to build a model in a distributed manner. So the data will reside at the source, and there's no data disclosure. That we could preserve privacy. And while the data requester can train the model using the data or the alternative data we call from the other parties, and there's no PII or raw data transfer to the data requester with data platform, so they avoid any security risk in the transit. So in this diagram, you see with this technology, federated learning, actually there's a lot of different multiple deployment scenario. The first one on the left is a company or organization. They have a different country operation or cross-department collaboration. They have a strict, data governance. They want to share data. The company can host a federated learning framework to collaborate the training across different country or organization. Or in the middle, we see a company with like a point-to-point, kind of a topology. A bank want to work with an insurance company, they could collaborate to do some prediction model. Or a company can work with multiple data provider to improve their propensity model. These are other deployment scenario. There are companies looking for external collaboration. The third one on the right, as more like a hub model. There's a centralized operator, and this operator align all of the data provider from different organization, and the data requester like company A, company B, they can tap into this network, and then they can access to all the data, alternative data of the data provider to do machine learning. So with this model, the company can easily get access to multiple alternative data from the data provider, and the operator as a facilitator, and they actually don't have the access to the data or the model. So with federated learning, actually they resolve the limitation of the traditional machine learning and improve the the data set for the data requester to do the machine learning. So with this, there's two categories of federated learning. The first one is on the left is called horizontal federated learning. it more like two companies. They come from the same industry. The diagram described that data from company A and data from company B. They have all the similar data set. They have all their own label. They do a supervised learning, but they don't have enough sample. So with a horizontal federated learning or homogeneous federated learning, they stack up aggregate ID to do machine learning. On the right, we have a vertical federated learning. It's other categories of federated learning is like a company B. They have the data set, they have the feature, they have the label, but they want to acquire alternative data from different sector, like a bank. They want to acquire the alternative data from a telco or from a retail, so they can aggregate the features. So this collaborating company, they will have a large overlap for the sample ID, but there are no overlap of features. So such that the data request that the company B can get alternative data from company C in the diagram to enhance the model accuracy with the alternative features that they acquired. So these are two categories of federated learning. So actually, our solution is open source solution. We based on the one of the leading industrial grade federated learning framework that already in the open source area for 4 years, as our company actually donated this framework to the Linux Foundation 4 years ago. And actually, we also a very proven track record of using our this framework to our own internal project. So OpenHive technology actually a solution come with a strong credibility. Differentiation is proven in the top global digital bank awarded by the Asia Banker. So with the strong technology background, with the experience, and we did a lot of real project that we proven that in our own company. This is one of the flagship product we call the SME lending solution that we as a bank, as a digital bank, as a data requester, we want to improve the accuracy of the SME credit model, because a lot of SME, they don't have enough credit data. So there's a challenges that when we want to lend some money to this SME, we have to acquire alternative data. So in this case, we acquire the alternative data from a large invoice data company in China. So with this, we can serve more SME, especially those usually rejected by the conventional bank due to their low income or due to their lacking of credit report. So with this, we able to extend uncollateralized loan to more SME with this federated lending model to do SME lending. So with this use cases, we want to promote the ideas to Hong Kong. So a few years ago, we collaborate with Hong Kong Science Park, and Hong Kong Science Park actually were helpful to let us to deploy our federated learning network in their HKSD platform. So we did first pilot project with a few of the major banks in Hong Kong, Bank of China, HSBC, and Hang Seng Bank. And Science Park will host a master node and connected this feedback with a simulated data provider like TransUnion and ourselves. So we validated a three-party joint modeling using federated learning based on a public data set of company bankruptcy petition. With this, we proved that it's secure and the model performance is nearly similar as accurate as traditional machine learning with a centralized location. So this published information, the data that are on the internet. So with this success, last year, Hong Kong MA, the Hong Kong Monetary Authority, also published a red tech guide, adoption practice guide in April, and saying that with federated learning, it could help the financial industry to acquire alternative data to improve the machine learning model. So with this, actually, we leverage a vertical federated learning, so the data requester and the data they don't need to exchange any PI information or raw information during the intersection of the customer database. During the model training, we use homomorphic encryption, such that we only exchange intermediate result partial gradients, partial loss in encrypted format. And when they do prediction, it's just changing some of the partial score. So it's preserved data privacy during the collaborative modeling using federated learning. So last year, around October time, TransUnion, one of the credit bureau in Hong Kong, also launched the first enterprise-grade federated learning data network, and with the partnership with us, they host a data network that could provide their own data, and company can tap into the network to do federated learning. So it's a major milestone that we see the development in Hong Kong. So with this, this year, actually we also did a lot of project. One of the project is one of the incumbent banks in Hong Kong. The retail BU of the bank want to identify potential of a selected segment, a younger generation of a bank customer. So they work with the partner, and the partner provide alternative data such that the bank could have a more holistic view of the younger generation. And previously, without federated learning, the partner won't disclose, all the data to the bank. So actually, this is already deployed, and the bank is looking forward to see what the impact, what the result of the model. The second project is a bank risk management division. The bank recognized that their own credit risk model could be using alternative data, not just their internal data. But actually, there's a very difficult for the third party to share the alternative data to the bank. With federated learning, the bank can work with that credit bureau alternative data to increase the model accuracy. So they run a pilot project this year, and we found that with the alternative data from the credit bureau, actually in the back test, in the sample test, we found a very significant improvement of the model accuracy, and the bank is looking forward to see how to deploy the solution in the near future for the production environment. So the last project we did this year is a credit bureau. They would like to improve its new to credit model and the SME credit model with alternative data such as behavioral activity and the usage data of some of the internet information, some of the browsing information. However, the alternative data source won't share such granular data due to data privacy concern. With federated learning, that two parties they can work together, and we test on a large customer set in these two organizations, and found that actually the alternative data partner could help that credit bureau. And that's another use case that we see the cross-industry scenario of using federated learning. So with this, we also looking at because the use case before we talk a lot of traditional or legacy machine learning algorithm like logistic regression, tree classification issue, but how federated learning could help the latest algorithm like generative AI, large language model. So when we're talking about large language model, we're talking about we are into the era of the machine learning AI. We have the pre-deep learning era, deep learning era. Now we are in the large scale era, and we need more and more data. We need more and more computing resources to do training for the generative or large language model. But as predicted by some of the computer scientists in the paper, we run out of data and analysis of the limit of scaling data set in the machine learning. A lot of high quality language data required for training large language model like ChatGPT will be deployed by 2026. Currently, most of this high quality data is obtained from public domain. Therefore, it's crucial to find a legal and compliant way to utilize private domain data while protecting data privacy to do this kind of training or tuning of the large language model. And also there's a data privacy or potential issue when building or using large language model with private data, domain data. And moreover, when we do a lot of tuning, we leverage a lot of CPU resources, GPU resources of that kind of algorithm. So is there any way to do it in a distributed manner, in a secure manner? So that's why this year in our Faith project, we add a new module we call Faith LLM. It's an efficient and private LM training with federated learning module. So with this module, we integrate various large language model for federated learning. And also we integrate a lot of different technique for the parameter efficiency tuning, such that the developer, they can easily do the parameter tuning, training the LM in a distributed secure manner with a federated learning concept. So the first idea is quite similar to the traditional federated learning with the horizontal federated LM. So in a fine-tuning stage of a heterogeneous or horizontal LM, how we could improve the communication efficiency. So based on the solution here, we tested that multiple enterprise can use their own private data to perform, horizontal or homogeneous federated learning using existing pre-training model like ChatGPT-2 and fine-tune the federated learning large language model. During the process, we have a secure aggregation server. This mechanism is to protect the model data for all the organizations involved in this federated training. By incorporating the training sample from different organizations, the model accuracy robustness will improve, while the data for all the participating organizations won't be disclosed. So with just like a traditional horizontal federated learning, but we apply it to the large language model, so they stack up the sample for the tuning, for the training. Another architecture will look like more horizontal one is a vertical one. So we are heterogeneous federated learning. So is it possible to perform, federated learning for different LM, like different parties, they process different resources like data, GPU, or they even own different, LM model? It's possible to use a solution called logic distillation. So with an aggregation server as a mental model to guide the mental model of this organization, and this organization will use their own model, own computing resources, and own data sets to do the training. At the same time, the aggregation server will help to consolidate, aggregate all the training result. So these are other new areas of how to use federated learning with the large language model. So the last deployment is it possible or how to use private data to fine-tune the LM model? So we're talking about the model owner and the data owner is actually two parties. So for these two parties to collaborate, it's imperative that the fine-tuning data remain confidential and not shared with the LM model owner. So in this scenario, we could use a technique called off-site tuning. So the model owner send a lightweight adapter to a Lucy, a compressor emulator to the data owner. So the data owner who can use this emulator to fine-tune the adapter on the downstream data with the emulator assistant. And the fine-tuned adapter is then returned to the model owner and plug into the full model. So with off-site tuning, we can achieve comparable accuracy at the full model fine-tuning. So there's a lot of active research on this area as well. So with emerging LM and the emerging federated learning technique, we could do large language model fine-tuning, training, segregation of the model and the data in a secure manner with the technique that I shared here. So all this information actually we publish in our GitHub. So if you have time, you can look at our GitHub, and FedLM is a framework to support federated training with large language model. As I said before, it also provide multiple parameter efficiency fine-tuning strategy for different applications and scenarios. With this, hope that with our technology on data collaboration with support of the traditional algorithm and the latest algorithm of large language model, we could help to build a data collaboration ecosystem that help the data requester getting data from the data provider or some company, they would like to have play the role of the operator to orchestrate, to how the collaboration across the community and make a bigger value from the alternative data from different data provider. So that's the end of my presentation. Feel free to contact me or return to the platform networking area, ask me question, look at our open source GitHub project. So let's pass the time to the MC.
Thanks, Kai, for his sharing on how to preserve the privacy in the generative AI use cases. Now, the next talk, we have the Benton House, Vice President, Digital Evangelism at Software AG. He will be talking about the security and secret, AI and APIs, the battle for privacy. Thanks, Benton.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.